in our next session. We extend a warm welcome to our resource person, Dr. Kapil Kumar Soni, Assistant Professor, Department of Information Technology, NIT, Raipur. And the topic for this session is Quantum Hardware Platforms and Implementation Challenges. As a mark of respect and gratitude, we now invite our Dean, Dr. Srinivasan, to felicitate our guest speaker with a short and memento. Thank you, sir. Thank you, ma'am. Dr. Kapil Kumar Soni serves as Assistant Professor in the Department of Information Technology at NIT Raipur. He has extensive expertise in quantum computing, artificial intelligence and cybersecurity, having delivered over 100 expert talks and authored multiple publications in Springer and IEEE proceedings. He is known for his research in quantum algorithms, simulation frameworks, and system optimization. In this session, Dr. Soni will present an overview of the leading quantum hardware platforms, including superconducting qubits, trapped ions, and photonic qubits, analyzing their scalability, coherence times, and technological readiness levels. We welcome you to deliver the lectures.
The topic first, but before that one, I'd like to extend my heartfelt thanks first to Professor Srinivasan for giving me the opportunity to interact with you all people through this ATAL sponsored FDP program on quantum computing and the technology. Okay, so and I am also thankful to the management, the people have invited me, and now giving us the chance for the further interaction. Okay, so before proceeding to our topic, because this topic is per the schedule of our FDP, okay, but I'll try to just take you all towards the tour of quantum computing. Okay, so first we try to understand the computing. Gradually we will be moving up towards the technological aspects. Okay, so the technological aspects will include both, that is the hardware followed by the quantum based platforms. Okay, so before accessing any of the machines, we need to understand about the hardware. Okay, because if we don't understand the hardware, then we cannot be able to program any machine. Okay, because the context is very simple. Like we people all are belonging to computer science, all the students. Okay, thank you. So it's a very simple context that if the people are learning a classical machines, what I used to call, okay, like the basic laptops, desktop machines you people are using. Okay, so these machines are based on classical physics. Okay, that is the first thing. But now the machines we people are going to learn here, these are fundamentally different machines. Okay, these are not the same machines as we people are studying in our computer science engineering courses. Okay, so what is basically distinct from a classical machine and a quantum machine, you first try to understand. Everything depends upon the information processing system. Okay, like in an information processing system of our what classical machines, we understand that everything gets computed in the form of what? At the lowest level of processing called zeros and ones. Means at the lowest level of processing we have the binaries based processing. Okay, like zeros and ones. Now there remains a misconception always to understand and to learn the quantum. Okay, that context is, it is following one property of quantum mechanics called superposition. Okay, so what in exact the superposition is, we will understand like with very vague example like we have zeros and ones in our classical machines, that is at the lowest level of processing. So in a quantum machine, we can have what? Zeros and ones to be processed together, or we may call it as zeros and ones both are processing in simultaneous manner. Okay, but the context is again very different, because if we see that zeros and ones are simultaneously processing, but it is not like that, because this processing system is completely different, I told. Okay, what happens when we deal with the classical machines? There are scalar values that is associated to zeros or ones, like the voltage level we used to always understand, yes or no? But there would be no chance of having direct zeros or direct ones like in the form of scalar values. So what we have? We have the vector of information here. Here in what? Quantum machine. Okay, so instead of dealing with the scalar zeros ones, we will be dealing with what? The vector of information that must be representing your zeros and ones. But what would be the form of representation? As you people have already gone through since the start of this FDP, I think you must have learned about that cat 0, cat 1. Do you understand that fact? Cat 0, cat 1? Yes? So what is basically a cat 0 and cat 1? This cat 0 and cat 1 are nothing but they are the column vector of quantum information. Clear? So these are actually the quantum states of information that is allowed for one qubit system. As I told, that the information processing system is completely different. We are not bothering about what? The zeros or ones. Like zeros or ones we are having at the lowest level of processing, but nowadays we are now gradually moving to compute the information in between zeros and ones. But in between zeros and ones, nothing can be computed. Okay, still we need some binary outcomes. Okay, so you please try to understand what is in exact the computation model. Okay, so I'll let you know with the computational model. First, let me proceed with this is the outline of our session. Okay, how we will be proceeding, that we will start with the introduction to quantum computing. Okay, followed to that one we will see that how a paradigms of quantum computings are available. Okay, followed to that one we will have a look over a technology development, hardware based realizations, and the technology oriented platforms. Like based on the hardware available nowadays, we have the different platforms to interact with the quantum machines, because these machines are not commercialized yet. We do not have the quantum machines like we are carrying our laptops. Yes or no? So just because of that one, we have some access to those machines, and there would be an interface that we will call it as a cloud-based interface. Okay? So through the cloud platform, we may be able to access the quantum machines. I'll let you know, because our today's session is immediately I just that is switched. Okay, to just take you towards a tool, towards that one. Followed to that one, we will have the programming framework, because being a computer science people, we are all about to do the programming. Okay, and why to program? We are just programming our machines. Yes or no? For certain solution of the problems. Okay, so for certain solutions of the problem, if we are going or we are writing a solution in the form of programming languages, so the similar programming languages are required for what? To write our solutions for the quantum machines. But again, the perspective would remain different. Okay, so you please try to understand, like a normal code we can write like using a C language, C++ language, Java language, Python language. Okay, but the same kind of language based solutions are not directly available here. We have to give our solutions first in the form of quantum circuits. So we will write the programs in order to generate the quantum circuits. Okay, because still there is no designated hardware which is commercialized available. Okay, so the thing is that we have to propose our solutions in the form of quantum circuits, so that these circuits can get executed on the quantum hardware. Okay, so I'll let you know that how the quantum circuits can be prepared and how these circuits be executed actually on the hardware. Clear? Now, followed that one, we will also look over the machine development challenges, what are still the challenges we people are dealing with. Followed to that one, the current state of quantum computing worldwide, including our Indians' growth. Okay, and at the last, we will have a concluding remarks with some summarized takeovers for what you people are here. Okay, these are some learning objectives and the outlines, that is the outcomes of our sessions. So we'll look over these all because the same flow I am not going to just refer here, because right now I am switched from my mind that how to just proceed with this session. Okay. So, but these are our objectives, that at the last you will be definitely known about these outcomes based on our objectives what we people are going to learn here. Okay. So the first one is understand the basics and the operational mechanisms of the different quantum bit realization technologies. Okay, because in order to realize a qubit, we have the different hardwares. Some materialistic based technological development is getting happened here. Okay, so based on those, the quantum machine, actual quantum machine development is in progress. Okay, another thing is we will see about the comparative advantages of these materialistic based technology. Okay, that how the quantum machines are now in a progress of development, and we will also look at over the state of the art and the future directions of the quantum hardware development, how we will be just proceeding. So these are our learning outcomes to understand the basic working mechanism of the quantum machine, how the quantum information is actually processed by the hardware, followed by the major challenges to build up these quantum machines, and the industry platforms which are available nowadays that will allow you to program the quantum machine. Okay, because we are only about to write the codes. Okay, but these code may be executed on your locally on your machine, that is like in my own laptop, or the code may also be run over the dedicated hardware. Okay, but the hardware is not directly accessible. The hardware is accessible through a cloud-based platform. Okay, so I will let you know that how we will be connecting towards a cloud-based platform. Okay, so now we come to the point. Okay, and let me take you all with the tour of quantum first. What you understand or what you have learned till date, I am just still expecting you all that you are at level 0. Okay, so you just try to understand, because everything starts from 0. Yes, if 0 is there, then only we may think upon 1. Clear? So the thing is that if I told you that everything starts from 0, means you just please try to assume that 0 is like a birth of any baby. What? Any baby in this real world. You just please try to correlate what the context I am letting you know. Okay, like a baby who took a birth, okay, on a particular date. So he or she is now considered as what? What to consider? Like 0. Okay. Here in a quantum context, that 0 would be considered as cat 0, because the scalar values of information we are not dealing. We are dealing with what? Vectors of information. Now why I am just correlating this context, you please try to understand. I think you people will definitely enjoy. Like we have two types of machines. Like this is the classical machine, like our desktop, laptops. These machines are deterministic in nature. What do we call? Deterministic in nature. Why we are calling them as deterministic in nature? Because these machines work on the lowest level of processing based on zeros or ones. Either 0 or 1. There are no further possibilities in between of zeros ones. Clear? But the quantum machines what we people are going to deal, these are not the deterministic machines. Rather, these machines are probabilistic machines in nature. Okay. What does it mean with the probabilistic nature of the machine? Means between the zeros and ones, there would be infinite possibilities that always remain within the quantum system. Understand or not? Like, before a birth of a baby, let me share you one more example. Like, if suppose I have a coin, okay, the coin is having two states, like head or tail. Yes? So because the coin is having two states, head or tail, if I toss a coin, the coin remains in a flipping state. Yes or no? Just please be responsive. Okay. If I toss a coin, the coin remains in what? Flipping state. Okay. So after the flipping state, the coin comes down to the ground. Yes. And we get the outcome as we were already expecting, either to be head or tail. That we were already known. Okay. That the outcome of tossing a coin will be what? Either head or tail with half probability. Yes or no? We know that there is a half chance to get our answer as head or tail. But nobody thought in the earlier days of like 70s, 1970s I was talking about. Okay. So that when I am talking about the flipping state of a coin, it always remains in a simultaneous superpositions of head and tail. So what does it mean? Simultaneous superposition means it's a linear combination of head and tail that must be simultaneously occurring. Yes or no? Once the coin is remaining in a flipping state. So at that time, we cannot let anyone know whether the head will come or tail will come, because we only know about the certain probabilities that are associated with what? Head and tail both. Okay? So this is a kind of computation we people now going to that is incorporate in a computing machine. Clear? But what would be the additive advantage with that? Yes, there exists advantage. Okay, and what is the advantage that I have wrote down in the that is point number 2. If you see, sorry, point number 3, that whatever the perception you people have developed, the simple computer science perspective is there that the quantum machine is allowing you to realize exponential number of operations in just a single step of execution. What does it mean? Exponential possibilities that can be realized in single step of execution. So what does it mean? Suppose like for a coin we have two possibilities, head or tail. Once we flip that coin, okay, so the possibilities that may be simultaneously occurring during the tossing of a coin, okay, that we need to capture here in a quantum way. So what it will give you the strength that we people have the advantage to see all the possible outcomes that are associated to the problem. Understood my point? What was my problem? I was thinking whether head will come or tail will come. Okay, but under that superposition, I can at least visualize. Yes, at least I can visualize that head or tail are simultaneously appearing, and any one of them would be the probable chance. Clear my point? Okay, but the classical machines were not given such a privilege to check these possible outcomes in like a tossing of coin. Okay, so whatever the machines we people are going to deal, called as quantum machine, these machines are based on uncertainties. Okay, so I started with what? Like a newly born baby. Yes, and what I told you, just consider that newly born baby as equivalent to 0. What to consider? As equivalent to 0. And we know mathematically there is no 0 available in quantum. Instead, what is available? Cat 0. Yes, like a vector of information. So now try to understand and correlate the context. Like a flipping state of a coin. Yes. So there would be some uncertainties that always gets associated with the flipping state of coin, until unless the coin does not come down to the ground. Once the coin comes to the ground, okay, comes to the ground, it would immediately gets turned either in the form of head or tail. Yes or no? But we would have known already the chance of measuring our answer. And we had already explored the possibilities to look over the all possible options. Getting my point? Okay. Like one more example before coming to baby again. Okay. One more example I am going to share. Like in a computer science engineering. Okay. We people are dealing with the processing architecture that is proposed by Sir von Neumann. Yes? So what is von Neumann architecture? We have some processing unit like CPU, we have some memory unit, we have input output units. Yes or? So for processing anything we need the information that is to be first stored onto the main memory. That is the key context, and I think you people must have learned the computer architecture till date. Okay. So as per the processing model, what the von Neumann says, that before the execution of any program, the program related instructions and the program related data both should be contained within what? The main memory. So once you load the program instructions and the data into the main memory, the CPU will be automatically able to fetch the instructions, decode the instructions, execute the instructions as per the instructions written by the end users. Clear my point? So the context is what? That the von Neumann said that everything should be contained in a main memory. Now again I am connecting you with the context of the quantum to try to understand. That a main memory, you are known that it's an addressable memory. Yes? So, and it is called as a random access memory. Irrespective of all the possible locations, like we have 4 GB of RAM. So means there are 4 giga locations. Yes or no? There are 4 giga locations, and at each location there may be some instructions stored or some data stored. Clear? But we can only be able to access a dedicated address of the main memory at a time. Do you agree or not? Can you be able to access entire main memory at once? Not possible. Yes? So we know, if irrespective of having 4 giga locations and we have stored everything in our main memory, our RAM is always be full. Yes or no? So the thing is that if we have stored everything in a 4 GB of RAM, so all the 4 GB of information can be accessed at a time or not? No. Because out of 4 giga locations, only one of the exact location can be accessed. And that is completely based upon the architecture what we people used to learn. Like memory address register, like memory buffer registers we are dealing. Yes or no? So based on the address register, whatever the value it contains, the dedicated address gets accessed by your machine. There is no provision of accessing entire RAM at a time. But now I am letting you know with one key context. Please try to connect. If suppose I have 4 GB of RAM, clear? So with 4 GB of RAM, what I told, that the quantum machine is capable of executing exponential number of operations in just a single step of execution. Clear? So now you please try to connect. For 4 GB of RAM, okay, how many locations are there? Like 4 giga. If suppose for students, if you are thinking like these are very large values, so you may only assume it to be like 1 kilobyte of RAM. For 1 kilobyte of RAM, what should be the size? 2 raised to the power 10 bytes. Yes or no? So how many address locations? 2 raised to the power 10 means still 1 kilo locations. Yes? Similarly like 4 giga locations. So for 4 giga locations, how many quantum bits we require? Like I told you that for representing zeros and ones, how many bits are required? That is quantum bits are required. 1 quantum bit. With 1 quantum bit, all the possibilities associated to zeros or ones can be combined. Okay, so the 1 qubit is enough to represent what? 0 or 1. Like 1 qubit would be enough to represent your head and tail. Clear? So for 1 kilo locations, like 2 raised to the power 10, how many qubits would be required? It is log 2 of 2 raised to the power 10 values. Okay? So log 2 of 2 raised to the power 10 values means what? Log to the base 2 of 2 raised to the power 10 values means it is equivalent to 10. Yes, log 2 to the 2 raised to the power 10. Okay, so it is equivalent to what? 10. So only with having the 10 qubits you can be able to explore what? 1 kilo locations of RAM at a time. Means that hardware is available and it is purely approachable. Clear? Means with 10 qubits of system, the entire 1 kilo locations of RAM can be accessed at a time. Now you increase this problem of accessing a RAM with 4 GB of RAM. Clear? If suppose you have 4 GB, 4 GB means what? It is 2 raised to the power 32. Okay, it is 2 raised to the power 32 giga. That is giga, it is to be said as 2 raised to the power 30. 2 raised to the power 2 is 4. So 2 raised to the power 32 bytes that are contained in your RAM. Clear? So for 2 raised to the power 32 locations, how many qubits we require? Log 2 of 2 raised to the power 32. Yes? So what is the value of log 2 of 2 raised to the power 32? It is still 32. Yes? So what is coming into our picture? That only with having the 32 number of quantum bits, you can be able to explore what? Entire RAM at a time. Means, what does it mean? You again try to means exponential possibilities can be covered in just a single step of execution. Means, we cannot get to know about the exact answer because still the model is what? Probabilistic in nature. Okay. But we could be able to see, okay, these all are the associated possibilities. Okay, for getting our solutions. Okay, so all possibilities can be explored at a single point of contact or at a single point of execution. Clear my point? So to cover the exponential possibilities, we have such a hardware like a quantum hardware is available for us. Okay, that is giving us the privilege to access the entire RAM in just single step of execution. It is just like a book. If you take one more example, if suppose I am having a book, okay, so if suppose book is having 1000 pages and I want to read the entire book, can you be able to read? No? Yes? I need to go through each page at a time, and since traversing all the pages, I may reach down to the last page of the book. But this is as per the classical processing, like what we have in our laptops or desktop machine. We have no privilege of getting the access about the entire book at a time. Means if you can be able to refer what? The entire RAM at a time, means everything is available for you in just a step of execution. Clear my point? Means it is just like a book. So once you are just turning down these pages, means you got to know everything about the book. Now I am known what is inside. Clear my point? So if I am known with this fact, so you try to understand how much the speed up we people are going to achieve. This is speed up. Yes or no? Do you realize that instead of executing, suppose like for 4 GB of RAM, if I want to access each and every associated address of a RAM, how much time we need to invest? Almost 4 giga time. Yes or no? If suppose we understand that one operation access requires a constant amount of time. Okay, so for accessing 4 giga locations, we need to spend what? 4 giga time. But instead of spending that 4 giga units of time, what we are interested in? We are only interested to execute everything in a single step. Clear? So for one step of execution, entire RAM is available. Like we are just turning down the pages. Turning down of pages is over. Just keep your book on the table and say that I have read all the content at a time. Clear? But everything is uncertain. Yes? If you are turning down the pages and claiming that I have now understood everything. Yes? So may or may not be possible. Understood or not? If suddenly I ask you the question, so you may or may not be answerable to that one. Clear my point? So sometimes in a probabilistic way of computation, you will get the correct answers, sometimes you will get what? Some non-desired answers. But our system will always approach to give you what? The correct answers. Okay, this is how the quantum system is getting developed. So the thing is what? Come again to the topic of what? Or the example of newly born baby. What I am still connecting, that everything is uncertain. Okay, now you start connecting with the qubit. What is happening? If a newly born baby is coming to this real world, it is just like a set cat 0, like a 0. Yes. So once the baby is alive in this real world, the uncertainties got automatically associated with the life of a baby. Do you agree with this fact or not? Not only talking about the babies, we must have been the baby, yes or no? Yes, at our birth time. And till date, if you observe your life, so your life always deals with what? Uncertainties. There is nothing deterministic. Clear my point? Everything is not deterministic. Everything is probabilistic only. And we did not have such model of computations earlier. Nowadays, we people are gradually moving towards such model of computation. You think by your own. When you start your journey to come or to reach to this college, either by bike or by walk or whatever the means of transport you people are using, is it deterministically true that you would reach the college? May or may not be possible. Always. Clear? I am not talking about you. Suppose I had started my journey yesterday. I was there in air. Okay. So that was not deterministically true that I should land safely. Yes or no? Because once I was there in the air, there was probabilistic ways, okay, to measure my possibilities whether I would land safely or I would not land safely. Clear my point? So the thing is that, like if you are alive, okay, means the uncertainties always be there, or the uncertainties will always be associated with your life. Nothing is deterministic. Suppose you are appearing to any placement activities, okay, for your placement activities, can you assure whether you will get selected? No, because if you are appearing, means there is a probabilistic chance whether you may get selected or you may not get selected. There is still a UP probable chances, like a tossing of a coin. Understood or not? So the thing is that if we are dealing only with the uncertainties, so do we have such a hardware or do we have such a quantum machine that can ask us or that can allow us to realize these uncertainties in the computing machine itself? Yes. Nowadays we people are having such a machines. Understood? And that we usually call it as a quantum machine. Understood? So the thing is that if like a newly born baby, what do we assume that one as? Like 0. In a quantum context, cat 0. Okay. So if I am saying that your life is all about uncertainties, so is there any possible outcome associated to your life? To your or including me also? Is there any possible or exact, what do we call, outcome that is associated to our life? Yes, definitely. And that possible outcome is what? That is to call it as a death. We all are known since the day of birth, yes, that we will have a date of death. Understood or not? So this is only the certain thing. Irrespective of all the uncertainties that we people are realizing in the today's living period, okay, only the certain thing what we people are already known, that is called to be a death. So similarly I am connecting it with you with the context of quantum. Okay, like if you are starting from 0, okay, so from 0 you are moving down to what? 1. And like a tossing of fair coin. So once you toss this fair coin, means simultaneous appearances of what? Head, tail would be there. Okay. Like if you are dealing with what? The quantum information processing system, there would be a possible chances of what? Cat 0, Cat 1. That should be simultaneously available in your system. Yes. But it is guaranteed that once your system will be over, it would definitely be collapsed into the possible classical outcomes. Yes or no? Okay. So the thing is that means each time instance we can measure whether I am dead or alive. Okay. So once you just think like if I am dead or alive, so 99 times, so you will be alive only. There would be only one instance that would be the dead instance. Clear my point? So the thing is that out of all the several possibilities, there would be a chance. There would be a chance to measure your answers. Clear? So now you connect with these possibilities. You see, this is the vector going on. Do we have pointer, man? Laser pointer? It's okay. No, it's okay. I just showed. No problem. So you see. It's okay. Now if you see, it's not coming. No, here coming, but here not. It's okay, no problem. Okay, you see what I am talking about. This is the classical bit. Okay, you please see. These are the quantum computing is all about mathematics. Okay, that is to be understood. This is the classical bit instances. Like I have specifically written it as what? Zeros and ones. But if you see the quantum bit formation, what I told that a quantum bit is what? A vector of information. It is not like scalar values like the zeros or ones. We have the vector of information in the form of cat zeros or cat 1. And how do we write cat 0, cat 1? You people have been learning since the day 1. How do you write cat 0, cat 1? Do we have any now listen here. If this is what? Cat 0. So how do we represent this cat 0? As a vector of information. It's a column vector of information. So how do we write this cat 0? This cat 0 is equivalent to what? 1 0. And this 1 0 is nothing but it is a 2 cross 1 vector. Yes or no? If you see, this is what? Cat 1. So the cat 1 is equivalent to what? It's a vector like 0 1 and it is still 2 cross 1 vector. What does it mean? Like if I am talking about a 1 qubit system. What? If I am talking about 1 qubit system. So associated to 1 qubit system, there are two possibilities. One possibility to have the quantum state as 0, another possibility is to have the quantum state as 1. Okay. And if you closely observe that within these possibilities of quantum states, like these are the representations of the vector information. Yes, there are some classical informations which are available inside. Yes or no? Okay. So if you think like that, it's like zeros ones. I did not say that it's a superposition of zeros ones. What I am saying that it's a superposition of what? Cat 0 and cat 1. And these cat 0, cat 1 both should be there in a quantum system. Understood? So for a 1 qubit system, there are two possibilities. So for a 1 qubit information, there are two quantum states like cat 0, cat 1. And both have been expanded over what? 2 cross 1 vector. Okay. And if you connect again if you are dealing with a 2-qubit system, for a 2-qubit system, how many possibilities? 4 possibilities. So with these 4 possibilities, do we write like this? It is like cat 0 0. Yes? How do we write? Cat 0 1, cat 1 0, and cat 1 1. Yes or no? We have these 4 possibilities in our system. Yes or no? So you people are known, but this is still the cat representation. Yes? But what we need? We need the vector-based representation of these quantum states. And how do we write the corresponding vector? It requires one operation. That operation is called as tensor operation. Yes or no? Remember? So how do we perform a tensor? If suppose I am working for 0 0. So how do we represent 0 0? This is cat 0. My font size are visible at the end. Okay. This is cat 0. What to do? Performing tensor with what? Cat 0 itself. If the cat 0 getting tensored with cat 0, it is equivalent to what? Cat 0 0. Yes? So how do we perform the tensor operation? Like this cat 0 is written as what? 1 0. And this is what? 1 0. Performing the tensor of information. Clear? So what it would become? It would become what? Like 1 tensor with 1, followed by 1 tensor with 0, followed by 0 tensor with 1, followed by 0 tensor with 0. If you assume it like in a computer science theory, like in a discrete mathematics connect, it is like a complete bipartite graph, nothing else. Yes or no? It is just like a complete bipartite graph where each element is getting tensored with what? The other element. Okay, now if we see, the outcome would be definitely what? 1 triple 0. Clear? Because 1 tensored with 1, it's 1. Rest of all values would be what? 0. So if you are writing this 1 triple 0, so this vector is basically what? 4 cross 1 size vector. Understood? So if it is a 4 cross 1 vector over 2 qubit system, so these 2 qubits are assuring that with the 2 qubit of system, you can be able to expand how many possibilities? 4. Yes or no? This is one of the possibility I have shown. How do we write this 0 1? How do we write? 0 1 is simply 0 1 double 0. Yes? How I am writing, I am letting you know. What about the next? This is what? 0 0 1 0. And at the last 0 0 0 1. Means what I am emphasizing right now. I was only emphasizing on the index position of the qubit quantum state. What I am emphasizing? The index position of the quantum states. What I call, like for 1 qubit system, how many quantum states? 2. Like cat 0, cat 1. Yes? It is for 1 qubit system. And you know that how do we write cat 0 and cat 1? Understood? So if it is 0, means my index position which is contained within that is 0. Means at 0th position, this is index position, this is 0, this is index position 1. Here I am writing it as index. Okay. So at 0th index position you put 1 for this cat 0. Clear? Similarly, if I am going to write down for this 1, so at index position 0 and 1, where to put 1? This is index position 1. So at index position 1 you put 0. Rest of all entries are set as 0. So this is how the vector actually being formed. Understood or not? So similarly in the same context, if you are just dealing with what? Cat 0 0 0 1 1 0 1 1. In a decimal equivalent of that one, it is written as what? Cat 0, cat 1, cat 2 and cat 3. Yes. So only you remember what? The index positions. Okay. This is what? Index position 0. So at 0 position, I have what? Applied the 1. Here, index position is 1. Means at the first position, you applied the 1. Here, index position 2. So this is 2. Index position 3, apply 0. Apply 1 at the index position number 3. Understood? Like this wise you people are known. Okay, like for one qubit system, there are two quantum states. How many quantum states? If you include both, how many quantum states? Two quantum states. Like for two qubit system, how many quantum states? Four quantum states. Similarly, if you expand the same system for n qubit quantum system, so how many quantum states would be there? 2 raised to the power n quantum states would be definitely there. Yes or? This is only the proof related to access all the address locations of your RAM. Understood my point? The RAM based addresses can be explored only by realizing these qubits in nature. Yes or no? If you are dealing with 32 qubits, all 2 raised to the power 32 possibilities would remain available in the form of quantum states. Okay, and these quantum states will ensure that to appear in a linear combinations. And linear combinations are nothing but they are realizing under a superposition. Clear? So this is the main concept based on which the quantum fundamentals are getting developed. Clear? So I think you must be known with the concept of superposition. It is just like our life. Our life is always remain in a simultaneous superposition of what? Either dead or alive. Understood or not? Each time when do you measure, you may be either dead or alive. Clear my point? And nobody want to become dead. Okay? It's okay. We should be alive at least. So this is what? Qubit realizing superposition. Now another fact. So this is like a qubit. Yes? And how do we represent this qubit as a superposition? This is the superposition aspect. Yes or no? That must say that the cat state 0 and cat state 1 both are appearing in a linear combinations. What does it mean? Means such to get such vector of information, there is equally probable chances to measure your answer as either cat 0 or cat 1. Now, very simple theory is this. If you are writing your superposition state like cat 0 plus cat 1 by root 2, so we know that this is cat 0, this is cat 1, as these two are the possible quantum state associated to one qubit system. What is 1 by root 2? How this 1 by root 2 is coming into the picture? How this 1 by root 2 is coming into the picture? And what in exact this root 2 be called? Why only this is to be called as 1 by root 2? I would have called it another also. But no, there exist certain theories. This is showing what? Uniform superpositions. What? Uniform. Uniform means there exist equiprobable distances. Equiprobable. So how this 1 by root 2 is determining with the values of equal probabilities? Okay, try to understand. Here in this context, 1 by root 2 is basically called as what? The probability amplitude. What do we call? The probability amplitude. And that probability amplitude is basically associated to each of the quantum states. What do we call? It is associated to each of the quantum states. Okay? So how many quantum states are possible for one qubit system? This is cat 0, cat 1. Only these two possibilities. So 1 by root 2 is the probability amplitude associated to cat 0, 1 by root 2 is the probability amplitude associated to cat 1. Okay, but still it is an amplitude. So when we will get the probability? We will get the probability once we apply the modulus square on this factor. What do we apply? Modulus square on this factor. So applying a modulus means always we are looking for positive values. Yes? Squaring the amplitude will give you what value? 1 by 2. Basically this 1 by 2 is the probability to measure your answer as either 0 or 1. Now remember my word. I did not say to measure the answer as cat 0 or cat 1. What I said?
0.
I am expecting to measure the answer as 0 or 1. Means like this. Like in a classical computation. So what is the difference here? Actually nothing or not at all everything is quantum. Please try to understand. There exist certain misconceptions. Okay, that the people start thinking like, okay, the quantum machine is going to replace the classical machines. The quantum machines will be going to replace the classical supercomputers. Also, they will become another supercomputer. Not like that. Okay, the things are very fundamental to understand. Quantum machines are only applied when there exists certain classical machine inefficiencies. Clear my point? Whenever your classical machines have certain constraints, means for the problems that the classical machine is not enough to solve in an efficient amount of time, then only we will apply what? The quantum. Otherwise, no need of quantum. If you have a machine which is enough capable of processing your solution in an efficient manner, why to apply quantum? Yes or no? If suppose there was an India-Pakistan war that was going on, if the work was already possible through drones, so why to send any missile? Yes or no? So this is like a system that we need to understand. Clear my point? Not at all everything is quantum. There would be a hybrid combination of classical machine and quantum machine. So what comes into the picture, you please try to understand. If you are belonging to computer science, I think you may be better connecting with that fact. One of the known full problem related to our quantum, that is classical algorithms domain, like dynamic programming, that comes to my mind, so I am giving you the example. Okay, like this is one of the possibility to explore all the possibilities of what? The solutions. Like a knapsack problem is very famous problem in computer science domain. How many are known with the knapsack problem? Have you heard it? Faculty members? Okay? Achha, chalo, it's okay, let it be. Let it be. That is still, you may take the basic example of accessing the RAM. Accessing RAM means it requires how much complexity? 2 raised to the power n. Because the RAM size is 2 raised to the power n cross m. Yes or no? So there are 2 raised to the power n address locations, and at each location there would be either instructions or what? Data. Clear? So the thing is that if you are dealing with the access of the quantum, with the RAM containing 2 raised to the power n addresses, these addresses can be accessed here with some exponential speedups or not? Yes, definitely we may be able to access. Because only with having the log 2 value of the all possible addresses with only the sufficient amount of qubits, all the RAM content can be accessible at a time. Understood? So the context is what? That we know that with certain speedups, we people may achieve our desired answers. Okay. So what will happen in the hybrid system? You understand? Initially, whatever the problem you have, okay, that you are expecting it to solve through the computing machine. Okay. So you come with your solution. So that solution should initially run onto the classical machine. Okay. So now the classical machine will check whether it is feasible to solve that problem with this solution in an efficient manner or not. If the classical machine understands that this is not feasible to solve this particular problem in an efficient manner, then only the problem will be submitted to what? To the quantum machine. And who will submit this task? Classical machine only. Okay, there is a controlling point that will be coming into the picture of the hardware that I am letting you know. Okay, so the classical machine will submit your task to the quantum machine. But what may be the possible instances you may be better connecting with? Yesterday you had a discussion on quantum cryptography. Yes? So if you remember my word, there is a Shor's algorithm. Have you understood? Shor's algorithm. Any discussion? Huh? Yes. So if you are connecting now, what is in exact Shor's algorithm? That is the classical crypto system security. That is, okay. A Shor has given a threat, or Shor has already proven a threat on a classical crypto system. How it is giving a threat? The very simple thing is that our classical crypto system are based on RSA. Okay, RSA is a standard algorithm for a crypto system. Okay, for performing the task related to the encryption, decryption. Okay, for some key exchanges also we apply. Okay, so the thing is that the security of the RSA system is completely relying on the prime factorization. Yes or no? What does it mean? What does the mean of prime factorization? Actually, for computing the keys in a crypto system like public key and private key, we require some factors. Okay, and that factors would be based on, suppose like I am having one number that is to be calculated with the value of suppose P and Q. So these P and Q are the two prime integers we people are computing. Okay, so if you please try to understand, if you are known with the value of P and Q, so do you have any algorithm that can give you the solution of n in an efficient manner? Yes, definitely, because only the multiplication is required. Yes or no? And our computing machine, not at all. We talk about the computing machine. Calculator is very efficient. Yes or no? But being a computer science engineer, we do not always think upon a problem for the small values of n. Okay? We always think the problems for the very large values of n. Suppose I am giving you two prime numbers like 3 and 5. Okay? If I am asking you to just multiply it and let me know with the value of n. Yes, sure, you will let me know that okay, 15 would be the result. But if suppose I will give you very large prime numbers, like in an RSA crypto system, there would be 2048 bits of information. You try to understand how much the complexity is actually involved in that system. Okay, so the computing of still the values of P and Q and to obtain the value of n is not at all a problem for a classical machine. But if suppose I am giving you the value of n like 15 and asking you to perform the prime factors or to find out the prime factors of that number 15, it may take time. And not only the time, even though for the present supercomputers I am talking about, they may take months or years of time in order to break this. Yes or no? Because still, do not think like that I am talking about what 3 and 5. Okay, the classical supercomputer will complete in just a snap of execution. Clear my point? I am talking about 2048 bit long prime integers. Yes or no? That is to be cracked by your classical supercomputing machine. So the machine is not enough capable. Okay. So if the machine is not capable, then we have to look for the quantum solutions. Clear my point? Okay. So like the Shor's algorithm, if you are connecting, so the Shor algorithm has given a proven fact that if you are known with this value of n, so the Shor has proposed one period finding routine. Through that, it would not take exponential amount of time to get this prime factors. Rather, logarithmic amount of time is only required to just get your prime factors. Now you think upon what is the simplicity in order to get your answers. Yes or no? But we are still not having such a consensus. Why? Because we do not have enough powerful quantum machine nowadays that can factor very large number like 204 bit of number with its prime factors. Clear my point? So this is the one key aspect I discussed. When a problem is coming to classical machine, so the classical machine has checked that problem is hard. Hard means it is computationally not possible to be solved in an efficient manner. Okay? Efficient means we should have a polynomial time solutions to solve the problem. Okay? At least an exponential amount of time if you are going to invest with the classical machine. These problems will be considered as what? The hard problems. Okay? So the thing is that if a problem is coming to the classical machine, the machine will check that okay, this is the hard problem. So for those hard problems, the task would be handed over to the classical, to the quantum machine. That is the first context. Second thing is, if you are dealing with certain problems, for those problems, you have very efficient solutions. Like you can solve the problems in polynomial time also. But the data which is associated to the problem, like in today's world, everybody is working upon what? Big data related processing. Yes or no? We are always dealing with the huge, very bulky data sets. Yes or no? So if you are dealing with very bulky data sets, so means that the complexity which is involved to process your data is not efficient by the classical machine. What does it mean? At least an exponential amount of time we need to invest for the processing of the data. Means I have the efficient solution, but I do not have the efficient processing of the data. So for that one again, I need to submit my task to the quantum machine, because the quantum machine is having the privilege of what? Of what? Of realizing exponential number of operations in just single step of executions. So if you have the exponential complexities of problem, so you can solve it through the quantum machine. Yes or no? Clear? And if you have the exponential complexity to process your data, so you may still solve that problem with the quantum machine, because the quantum machine can yet explore entire RAM content at just a single step of execution. I think you may be better connecting with that fact. Yes or no? So these are the two possible very broad contexts that I told you, that is relating you with the processing of what? The quantum machine. So I said everything is not quantum. Clear? It's what? Classical quantum hybrid architectures. Yes or no? But at all, the context comes into the picture. Like a flipping state of a coin. I flip that coin. So we have the computation power that under the flipping state of a coin, we can get to know, okay, there are two possibilities of our outcomes. Clear? Okay. But at the last, when the coin comes to the ground, we only get either of the possible answers. Yes? Either in the form of head or in the form of tail. So the context is what? Like a quantum, like a classical computing system. We have, or we are looking for what? We are looking for what? The classical output. Okay? So irrespective of the quantum processing, because we are only including the quantum processing to get the solutions in an efficient manner. Understood? But after all, we are only getting the solutions in the form of classical outputs. I think it is connected. Okay? So what does it mean? It is just like a measurement process. Okay? Once you have explored the quantum system, so your quantum system would be the comprising of all the probabilities that should be associated to your problem. Clear my point? Yes or no? If suppose you are hungry, okay? If you are hungry and you are checking your pockets, there exist some pennies. Suppose like 10 rupees I have in my pocket. But if I am going to any shop, okay, at least for a samosa or idli, okay, they are charging for 20 rupees. So what does it mean? Instead of having 10 rupees in my pocket, I may or may not have my food. Getting my point? Because everything is uncertain. I told you, I started with the concept of uncertainties only. We always deal with what? Uncertainties. Clear? But at the last, there would be classical outcome. If suppose the idli wala is charging what? 20 rupees. So I would be happy with hungry. Clear or not? And if suppose I have 10 rupees in my pocket and they are charging 10 rupees, so I would have my fee. Yes or no? So the thing is that the outcomes what we people are looking at is completely deterministic. So that is why it requires the measurement process. What? Measurement. Means after every quantum computation, we require what? Measurement. And the measurement will lead you or will take you in order to get the desired answers. Getting my point? So the context is what? Once you explore your quantum system, that quantum system would be fully comprising of all the possibilities or all the probabilities that are associated to your solutions. Understood or not? So out of them, we are only approaching towards the desired answers. Understood or not? We are only seeking for the desired answers from the system. And associated to the desired answer, there would be certain probabilities. So we will receive our answers from the quantum machine, but with certain probabilities. Okay? And these to be compromised as well. Clear? I'm just explaining. So it's around 4. Schedule is up to 5:30.
No, 4:30.
It's 5:30.
4:30 is hands-on.
4:30 how long?
Hands-on.
Achha, another session. So there will
No,
be.
sir, we can combine for today. We are taking there, we can consider that itself as hands-on and
So I'll take that as well. No,
Yes,
problem.
yes.
No.
That's okay. So now you will see.
You something break for it.
Just let me complete with that.
You
Sir.
complete, sir, we take after.
So you
we
see.
take after, sir.
You see here. What is actually it's not displaying here.
No, but you press that cancel. Here, you press that cancel. It automatically comes.
Achha, it's okay.
Yes, now you.
Now you see. Now you see. What is happening here? As I told, as like a newly born baby. Once you just follow this vector here. This is the IBM based vector. Okay, that is to be realized for each qubit. So every qubit is just looking like as a wave particle duality like things. Okay, it is following this property of wave particle duality. Like you are considering your quantum as a particle. If suppose like a ball you have in your hand, if you are throwing your ball from one end to another end, so it's up to your perception how you are visualizing your quantum particle. As either as like a particle instances or you are liking it to be a like wave. Clear my point? So this is just a waveform. If you see, it is always starting from what? You see, it is starting from cat 0. Clear? And once we put this qubit into the superposition, it immediately comes down. You see, from 0 it is coming down to x. You see, first. Is it coming down? From this cat 0 immediately, once it comes down here, it comes down here. Yes? And after that one, it just make a circular rotation on this elliptical curve. Okay? What does it mean? This will show you the uncertainty. Okay? This is the certain thing, cat 0. This is another certain thing, cat 1. Clear? So, after remaining into the uncertainties of your system, you will get your answer either to be measured as 0 or to get your answer as 1. Clear my point? So the thing is that this is all about the qubits which are realizing the superposition property. But what about the entanglement? Do we have any entanglement property? You think start, because I told everything whatever we people are just realizing in the form of computing hardware, everything is actually happening with us. We people are the humans. Yes, we are developing the machines. Clear my point? So like I told, we people are investing our time for the probabilistic ways of computation because we also deal always in a probabilistic ways of computation. Yes or no? We are not deterministic at all. Like I have given you the example of what? Pockets. Clear my point? So the thing is that if we are dealing with the probabilities of the system, so superposition exists. Yes, means there is a linear possibilities of your possible answers. So entanglement really exists or not? What does the mean of entanglement? That is what we have quantum bits which are correlated with each other. What do we call? quantum bits which are correlated with each other. Means they are strongly connected with each other. Okay. Symbolically or mathematically, if you see, so if this is considered as one quantum bit, okay, this is realizing up spinning state of an electron. Okay. Here, this is realizing the down spinning state at the another quantum bit. If these are the two separate quantum bits, so if we have any circuit settings through which if we can combine together both of them, then both of them would be there either in an up spinning state or both of them would be there in a down spinning state. How it can be happen? The very interesting context to be understood here. Okay. I am letting you know I have one quantum bit, another quantum bit, and I am making the quantum bits correlated. So once you perform a measurement on the one, the instantaneous similar measurement is getting happened on the associated qubit. Clear? Means if it is up, so another would also be up. If it is down, so another would be down. And this is one form of the entanglement. I did not say that this is only the form of the entanglement. Okay, there are 4 different possibilities through which you may realize your form of entanglement. This is one. And this one form of the entanglement basically known to be a likely entanglement. What do we call? Likely. Okay. Like giving you one example. Already told. Everything, whatever we have in our mind, the same computing aspects people are implementing in our quantum machines. Okay. Try to understand the fact. Being a human, do we have any entanglement? Can we correlate it? Can we have strong connections? Yes. In this context, you people may understand. Okay. We may have the strong connections with each other, being a human. Okay. Strong connections, you people may consider anything. Like in a friendship relationships, like in a husband-wife relationships, you may consider by your own. Based on your perceptions. Clear?
Morning sir gave an example of twins.
What?
Morning session sir gave an example of twins.
As a twins. So that is like-minded. So the thing is that if we are dealing with what? The two people. If we are dealing with like you and me. I am taking this session. If suppose you are perfectly synchronized with my intellect. Clear? So the thing is that whatever the things I am letting you know, you must be convinced. This is what? One form of the entanglement that we call it as likely entanglement. Okay. If I am saying yes, so you must be believing that yes. If I am saying no, so then you must be believing it as no. Clear? So this is based on what? Likeliness. Another form of the entanglement can also be formed. That is called as complemented entanglement. Like whatever I say, if I say yes, you must say what? No. If I say no, you must say what? Yes. This happens after very old ages, okay? And perfectly in suppose I think I should just drop this. Just look at it. So the thing is that if we have the complementary relationship also, means one says yes, another says no. So that would again be possible. It doesn't mean that the people are negative. People may be constructive again. Clear? But for certain thoughts, we people are looking for plus and minuses. Okay? So now the thing is coming into the picture that entanglement is also existing in this real world. That is why it is being simulated here in a quantum phenomenon. Okay? And not yet. This is actually be realized over the hardware. And this entanglement is a key theory for the realization of the dead quotations. Clear? Now, another fact is the parallelism. That is all about what we understood. That is exponential possibilities can be realized in parallel. Okay? Now you see, coherence. What does the mean of coherence? That is the stability associated to your qubit. What is qubit? Qubit is actually realizing what? It is realizing what? The possibilities of cat zeros, cat ones simultaneously. Yes or no? So how much would be the longer time that it should preserve the same property? Okay, that is showing what the stability associated to your qubit, and that is the coherence. If the coherence get lost, your system must be turning down to the classical outcomes. Clear? So, in respect to that coherence, if you see, in respect to that coherence, I have one transition, and that transition I have given as name as what? Decoherence. Okay? So what does it mean if you see? This is a quantum state of the system. Head and tail, they are simultaneously appearing. Okay? Once this decoherence transformation happens, transition happens, it immediately turns down either head or tail. So what may be the possibilities when we may realize this decoherence as the possible transitions? Number one, that is intentional, and that intentional decoherence transition is known for the real world as measurement. What I am calling? Measurement. After exploring your quantum system, you know all the possibilities. Now you are going to measure your desired answers. So once you are going to measure your desired answers, okay, you will get your answer with certain probabilities. Okay, but after getting your probabilities of the system, you will get definitely a classical outcome. Yes or no? So for that reason, we require what? Decoherence. So decoherence, one form is what? To perform the measurement. So once you perform the measurement, this decoherence will automatically be done. Another, this is unintentional, where we are not applying any intentional possibilities. So that unintentional possibility is dealing with what? The noise that is associated or remains present in a quantum system. What I am calling? The quantum system is present with the noise. Noise may be internal, external. Clear? Because of the presence of noise, your quantum state of the system will be definitely lost. And if arbitrarily at random, it will come down to either head or tail. It will not bother at all about your desired answer. Getting my point? Okay. So there are two possibilities through which you may achieve what? Your decoherence as one of the possibility of the system. And decoherence means loss of stability. My quantum state of the system is completely lost. It is turning down to what? The classical state of the systems. Clear my point? Yes. Another fact is what? Interference. As already I told that everything is probabilistic in nature. Yes. If we have a likely mindedness, okay. If we are likely minded, okay. So our corresponding frequencies will be added together, and we have the higher amplitudes. Yes or no? And if we have the complemented kind of interferences, yes. So there would be what? Negligence of the amplitude. So now, what is the desired system you try to understand? If the amplitude associated to your answers are slightly or very high, then once you perform, okay, this is lost. The written facts are lost. So how do we get the probability associated to the system? I told 1 by root 2 was what? What was 1 by root 2? Probability amplitude. Yes, it was amplitude. Yes. And once we apply the modulus square on 1 by root 2, you will get what? The probability associated to your answer. Now I am connecting it to you here. If you have the higher amplitude, maximally your amplitude would be what? 1. That is like a sine wave. Clear my point? Clear? So the context is that if you have the maximum amplitude as 1, applying a modulus square on that one will always give you the value 1. Yes? Means you have the 100% probability to measure your desired answer. And if you have like this negligible amplitude, there is no amplitude present in this system. Yes or no? This is destructive interference what is realized under the quantum state of the system. There is no amplitude, means amplitude is 0. Applying modulus square, you will get what? 0 is the probability of measuring the answers. Clear my point? And if you suppose have in between, that is called a superposition of measuring your answer as either 1 or zeros. That is called to be as 1 by root 2. 1 by root 2 in the context, probability of measuring your answer as 1 by 2 only. Yes? And in the morning session itself, you must have understood this fact. Whatever the quantum solutions we people are going to process, okay, these solutions must be based on quantum circuits. Yes or no? We started that how to program a quantum machine. Quantum machine means how to program or how to run our solutions in the form of quantum circuits onto the quantum hardware. Clear? So for that context, every quantum circuit is a collection or composition of quantum gates. Okay? So based on quantum gates, your quantum circuit gets processed by the quantum machine, and at the last, you know what to be performed? Measurement. Why? Because we have to collapse the quantum state of the system and come down again to the classical states of information. Understood? Okay. So that is why I have just written down here that quantum circuit is always equivalent to what? An algorithm. Like in a computer science theory, it is written fact called to be as Church-Turing hypothesis. It was a hypothesis in a computer science theory. What about the Church and Turing hypothesis? That the Turing machine is a processing model of the computing system. Yes, it was processed. It was proposed first. So equivalent to every Turing machine, there must exist an algorithm. Yes, and for every algorithm, there must exist a Turing machine. This was the hypothesis the people have come up. Clear? Church and Turing both. Okay, so it simply means if for any problem you are proposing your solution in the form of algorithm or in the form of Turing machine, both solutions are acceptable solutions. Clear? So similarly here in quantum context, okay, in a quantum context, if you are proposing your solution in the form of quantum algorithm, so you may propose, but understand very true fact. Like, first let me discuss, like we usually write the programs, yes, in what kind of language? High level languages. Yes, you say, I write the program in high level language, C language, C++ language, Java I use, Python I use, so many languages I may use. So the thing is that, why you are only writing a solution in such language that cannot be understood by the machine? The machine does not understand your high level language programs. Why you are writing the solutions? Huh? Somebody is there who is taking the care, like compilers, yes or no? Like the translation tools we have, and these translation tools are taking the part of getting your high level language as an input, and it is translating it into the low level language of outputs. Okay, so based on that low level languages, your machine actually executes the program. Understood? So we need some translator programs. So that was the key fact. What does it mean? There is a communication gap between the humans and the machines. We propose our solution in the form of high level languages, but the machine does not understand that language. It used to process the solution in the machine language. Clear? So similarly, you may propose your solution in the form of quantum algorithm. Quantum algorithm means it's for your understanding purpose. You may write your solution in the form of algorithms. Okay? But such algorithms cannot be directly executed on the quantum machines. So what to do? Here, the compilation related overhead and the compilation related task would be done by two types. One, that is to be done by the manually done by the user itself. We have to transform our quantum algorithm into equivalent quantum circuits. Why? Because we know that the hardware is only allowed to run the quantum circuits. They cannot run the algorithm directly. Okay. So we need to transform our quantum algorithm in the form of quantum circuits. Clear? So once the quantum circuits are ready, these circuits can be executed on the quantum machine. Understood this fact? Okay. So this is a very general term that you need to understand that for algorithm we people may propose, but for the execution model we require what? Quantum circuits. And the quantum circuits are only made up of quantum gates. So for that one you people have already covered. Yes, quantum gates you have done, quantum circuits you must have done. Now our today's context, we will approach that how to program a quantum hardware using some quantum programming framework. How we will be just accessing the quantum hardware with some programming languages. So are there any programming languages available like you are known with Python? Yes? Yes, definitely. We have very popular programming languages and not at all a single one like Qiskit. Qiskit is very popularly known programming language to program a quantum machine. Okay, and this Qiskit is completely based on Python based framework. It's a Python based framework, nothing else. But it doesn't matter, it doesn't mean that only the Qiskit is the requisite programming language to program your quantum machine. We have other programming frameworks which are equivalently doing better, okay, than your Qiskit programming framework. Understood? Like Google Circuit, okay, like Penny, okay, like TensorFlow, quantum TensorFlow. It's a specific library we people are having to program our quantum machine learning models. Okay, so now the thing is that there are several popular programming frameworks for which we people are working. Okay, so our ultimate task is to understand that how the quantum machine is actually processing our task, okay, and how to write our solution in the form of quantum circuits, okay, and how to code actually these quantum circuits so that the quantum circuits can be executed on the quantum machine. Understood? What are the key objectives right now? First, to understand the quantum processing architecture, that how your quantum information is actually processing by the hardware, okay, or by the quantum device. Next, how to propose the solution in the form of quantum circuits through the quantum program. So we will write the quantum program using quantum programming framework. Okay. So by using the quantum programming framework, we will write some quantum programs. These programs will automatically convert your solution into the form of quantum circuits, and these circuits be actually executed at the hardware. But not at all at the hardware. You may also execute your task locally onto the classical machine. How it is possible? Based on what? The simulation. Okay, your quantum behavior can be simulated by the classical machine. Okay, so I will let you know with how the quantum computing paradigm is actually available for us. Okay, in the connective session, because it's time of tea break. Sir, should we move? Yes. So I will connect with the theories related to the intentional and intrinsic parallelism, because computer science is all about parallelism. Okay, so I will connect it with in the later sessions, whichever is scheduled in the lab. Okay, so I will again take around 1 hour of theory lecture. Okay, almost you are, I am assuming it to be that you are comfortable with the fundamentals. So if you are now cached with the fundamentals, means everything is there in your cache memory. Okay, I am assuming, then everything will be fine from my side. Okay, so just please be connected in the next session with process. That is in lab. Which lab?
Opposite.
And opposite to this room. Okay, just please proceed after having your two sessions. Down to programming topics. Just please settle down. Are we ready? So let's move. Okay. Board is visible. Now visible. So now please resume with our discussions that was going on. That for computer science, perspective to computer science, just please switch off these fans. It is possible because is it required? Then I switched off mine also. Just to cooperate. Because some echoing of voice I am realizing. Because due to this mic also and another one, the noise coming from the fan. No, thank you. Almost noise over. Now, listen. The context is very simple. Being a computer science engineer, we are all about to do the parallelization of the task. Yes? And why we do the parallelization? Just to attain some speed ups in the computational results. Yes or no? And we know that the quantum machine is enough capable of giving you the exponential speed up. Okay, because the exponential number of operations can be realized in parallel or in just a single step of execution. So if you see, this is very general classification scheme I used to discuss. Okay, this is one of my proposed scheme, that is in an intentional parallelism. I have made these with the two categories. That is, the first one is intentional parallelism, second one is intrinsic parallelism. Means the classical hardware is not developed for realizing the intrinsic parallelism. Means the machine is not supporting any parallelism. So, is there any chance to realize the parallelism? Yes. We have the chance to realize the parallelism within the machine. How? At the lowest level of processing, if you think, there is a pipelining process. Yes? In the computer architecture, people may understand. Okay, at the lowest level of processing, we have the instruction level pipelining. Okay, followed to that one, we have the threading, that is multi-threaded environment. Okay, we execute a task in multi-threaded environment. Coming up, we can execute a task in what? That is multi-core environment. We have multiple cores in our machines. Yes or no? We have multi-processor based machine. A single machine is containing multiple number of identical processors. They must be connected with certain topologies. Okay, and we have the cluster of nodes also. Okay, that is the parallelization of any task. We have certain levels of parallelism that we may achieve through what? The classical computing aspects. Okay, so the Flins has already proposed the corresponding classification as based on the instruction stream and data stream. Okay, and we know these are the famous classification scheme called as SISD, SIMD, MIMD and MISD. Okay, so if you cover these all four classification schemes, this is not the context to discuss. My context is what? That is how to discuss with the intrinsic parallelism that is supported by the quantum machine directly. Means nowadays, if people are going to develop a machine, that machine is by default giving us the parallelism. There is no need to include the parallelism at the different levels of processing like we do in the classical machine. Okay, so if we have any hardware that can support such a parallelism, so that would be convenient for us. Yes or no? And we know that the exponential number of operations can be realized in parallel, so that would be fine for us. So in respective to each of these, like SISD, SIMD, MISD, MIMD, we have the four classification schemes based on the intrinsic parallelism of quantum computation. Okay, that is classified based on the type of data and the type of algorithm. Okay, so the first C stands for here, the classical data to be processed by classical algorithm. Now you may think that classical data, now you understand that the classical data is different, quantum data is different. Do you agree with this fact or not? Huh? What is classical data? 0, 1. What is quantum data? Cat 0, cat 1. Yes, it's a vector. So now the thing is, if you have the classical data processed through the classical computer, means is there any parallelism we are achieving? Yes. The parallelism what we can achieve through these classification schemes. Clear? But irrespective to this, if you talk about the classical data to be processed by the quantum machine, okay, that is a kind of hybrid architecture. We always have the classical data, okay, and that classical data needs to be processed by the quantum machine. We know that the quantum machine cannot process the classical data because the information processing system is completely different. Yes or no? The quantum machine will not understand 0, 1. It will understand cat 0, cat 1. So our first responsibility is what? Is to convert the classical data into the quantum compatible format. Understood? So that requires the quantum data encoding. Clear? So once your data is prepared in a quantum compatible format, then only it will be processed by the quantum machine. So that comes under what? CQ. Clear? Now the another is quantum data to be processed by classical machine. We know, yes, that the quantum data cannot be processed by classical machine, but there is a chance. There is a chance through which you may what? There is a chance through which you may realize this quantum data onto a classical machine. What is the chance? I'll let you know. I'll connect in the further slides. Okay, that is basically called as quantum inspired computing. What do we call? Quantum inspired classical computing. So basically we will implement some behavior of quantum system using the classical computations. Okay, so based on the classical computations we will execute or we will simulate the behavior of the quantum system that comes under QC. Clear? Okay, followed by this QQ is the ultimate target. Actually we are seeking for the solutions where the quantum data remains quantum and the solution to be also processed by the quantum machine. Okay, and straightly just looking for the solutions to be solved by the quantum machines because we know that the quantum machine can execute what? Quantum circuit. And quantum circuit is equivalent to what? Quantum algorithm. Yes, and quantum algorithm is the solution we used to write for any of the problems to be solved by the quantum machine. Yes or no? So based on these factors, we people are having our model. So where we are now? We are now at CQ. Okay? The classical data that is being processed by the quantum machine. We have to take care of converting our data into the quantum compatible processing format. Understood? Okay? Now if you see, this is very basic example. Okay? So very basic example I have included here. If you see the two computing models, this is classical computing model, this is quantum computing model. For any computing model, what we are supposed to give as an input? For an input we require what? The program that is to solve the problem, yes, and we need the data. So the program and the corresponding data we need to give as an input, the machine will process accordingly and generates the output. Okay, so here I have taken a very simple context of searching. Okay, so searching over an unstructured data. If suppose I have very unstructured data like 3102 and its binary form is already written in the form of 1101 like this one. Okay, because the time is also limited, so I am not going to waste. Okay, just please try to understand the context. So the thing is, if we have the unstructured data over which I am going to search for what? 2. Okay, whether 2 exists in my database or not, I need to search it for. So the linear searching program, like as one of the possible searching program, that is to linearly come down to each of the index location and search for a possible existence of the element. If the element exists at a particular index location, then the corresponding index position will be written by the program. Yes or no? So based on this classical computing model, this model will actually execute the quantum program based on this data and will generate the output, because we know that the 2 exists under this input data. Yes or no? If the same task to be done here by the quantum machine, so if you see what is happening here, like in the previous model, the computation what happened, but the computation was completely mutually exclusive. Yes or no? Because the answers or the resultants we got, these were completely deterministic. Yes or no? But here we require what? The probabilistic ways of computation. So here you see, instead of classical linear searching, we have some quantum searching mechanism. Grover's mechanism is done or not in your FDP? So maybe later on or in your schedule course, please check if Grover's is one of the very fine searching mechanism. Okay, that is sir is confirming that tomorrow you have the session. Okay, so the algorithm actually you learn. Okay, but I am just giving you the that is concept here. Instead of applying this linear searching, if you apply the quantum searching on the same data, but you look at here, the data is not classical. I have converted the data into the quantum compatible processing format. Like see, 3102 all have become what? Cat 3, Cat 1, Cat 0, Cat 2. Yes or no? And over which we are looking for the class, that is the index position of the data. Yes or no? Now based on this quantum searching, the quantum model will process and it will finally generate the output that yes, 2 is existing. 2 is existing means the element 2 is existing at certain index space. Yes, and we know that here if you observe this as in the form of array, so this is the index position 3. If you start from 0, 1, 2 and 3. Okay, so at the third index we found what? That the element is existing. Clear? So now the context is what? That based on, instead of applying the linear searching mechanism, if we have applied here the quantum searching mechanism. Okay, so based on this quantum searching mechanism, we also got the CMOU. Yes, because we know the measurement of the quantum system will take you towards the classical outcome. So still the outcomes are same. Okay, you see, the outcomes we have not put it with the Cat 0 or Cat 1 format. Yes, at the output I did not apply any Cat notations because entire output of the system is completely classical. Clear? But we know that the quantum model is actually processing on what? The qubits of information. Okay? So this is a very basic thing to understand that overall, because as I told you, the quantum system will be comprising of all the possibilities including the probabilities of the associated values or the possible answers. Okay? But from them, we will only extract the desired answer with high probabilities. Okay? So now, this is a very basic thing to understand that how the classical computing will happen and how the quantum computing will happen. Okay? So now in the classical computing, you know that whatever the problem you are going to solve, you need to code that problem. Okay? As in the form of algorithm, because algorithm you should have as a ordered or the sequence step of that is steps to write the solution for a problem. And the algorithm you need to convert into what? In any of the programming language model, so that the program will be executed onto the machine. And you know now that the program, what you are writing like in the high level language, that is not actually executed. It requires compilation task again. Yes? So now after that one, your task will be compiled by a compiler, finally it will be executed onto your hardware and the binary outputs are coming to you. Yes? Now, what happens with the quantum computation here? Now, you have the quantum algorithms to solve the same problem. Like in a linear search, you have the quantum searching problem. Yes? So, quantum searching algorithm to search for unstructured data. So, now the problem is to be solved through the quantum algorithm. Now, that problem has to be programmed for quantum circuit. Because as I told you, we will write the program so that program will convert the solution in the form of quantum circuit. Okay? Now that quantum circuit will be compiled by the hardware, okay, based on certain compilers. Some optimizers we are also applying here. Okay? There exists certain that is task that is to be handled by the optimizer. I will discuss with the programming framework. Okay? Under that framework you will get to know that what are the possible things or other components which may come into the picture for the entire execution of the task. Okay. At the last, we will see what? The probabilities of the output. Okay, because the outputs like head and tail, okay, like zeros and ones. I think you have already learned about the Hadamard. What is Hadamard gate? What is Hadamard? Chalk, please. This one? What is Hadamard? If you are dealing with cat 0, yes? So Hadamard is actually a quantum gate. Okay? That quantum gate, if you apply onto the cat 0, it transforms your quantum bit into what? Into 0 plus 1 by root 2. Yes? This is called to be a superposition state. Okay? And this superposition state you may only observe when you apply the Hadamard on the cat 0 state. If you observe or if you apply the Hadamard on cat 1, you will get what? Another superposition possibility, that is understood by what? Cat 0 minus cat 1 by root 2. Yes? And there is no fact or there is no problem happens with plus and minus, because the amplitude associated to your quantum states are what? 1 by root 2. Once you apply the modulus square, you will get the corresponding probability amplitude. Yes or no? And it is still remaining as what? 1 by 2. Because there is a half chance. So the context is very simple, that if you know that the quantum gates are actually applied for the realization of your quantum based task, so the composition of all the gates would be called as quantum circuits. And quantum circuits would actually be taken as the consideration of quantum based solutions that is to be executed. So we will be writing some quantum programs. So those programs will actually generate the quantum circuits. So that quantum circuits will be actually executed either on the quantum simulator on your classical machine or on the quantum hardware. Okay? And we have one more task, that like a quantum inspired computational task we can perform. Like we may execute the task in the form of classical computation in order to realize the quantum behavior. Clear? So this is, that right side is just showing you the hybrid cloud environment. What happens, you look at the board. You look at me. We have the quantum machine, but that quantum machine is not commercialized and we do not have such machines in handy manner. Yes or no? So there is a dedicated quantum machines, like IBM is having a machine. Okay? So that IBM machine is located at different geological locations. Okay? We only know the logical names of the quantum machines. So through the cloud-based environment, we actually use the quantum machines. Okay? So we write the solution. Okay? We try to execute that solution to run on quantum machine. Understood? Okay? So irrespective of the geological or the physical location of the quantum machine, we want to run a task onto the hardware. Okay? So this is the very basic architecture that is available on the right side, because it is not only for the hardware to understood, okay? Hardware along with the software along with the cloud environment framework, what we need to program a quantum computer. Understood? Now, this is to understand the quantum computing significance again. What is basically a significance? That what do we call? High speed of computation. How to just cross this? No cross. This one? And now you will see. So, what are the advantages? First one is high speed of computation. Do you agree or not? Exponential operations which are realized in parallel in just a single step of execution. So it is what? High speed, very high speed. Okay. And it is giving you what? Intrinsic parallelism. Instead of intentional parallelism, what we have to incorporate in the classical machine. Like this machine is having quad core processor, hexa core processor, yes or no? Or octa core processors. So these are intentionally made by humans. But in a quantum machine we do not need.
only need the hardware that should simulate the behavior of superposition. Yes or no? Now another thing, it is suitable for compute intensive and expensive job. I have already discussed. Intensive means hard to solve. Okay, the problem which is hard to solve. As I told you, prime factorization is still a hard problem. So that a classical crypto system is still reliable. Otherwise, our banking, passwords, OTPs, everything will be going in a understood. So the thing is that we have the hardness of the problem. Okay, and to crack that hardness, we have the quantum-based solution. Yes or no? That is why the Peter Shaw has already posed a threat over a quantum machine, over a classical crypto system. Clear? And in 1994 itself, I am not talking about this decade, okay, almost 30 years back. So now, it is also suitable for expensive job, means the data which is requiring at least an exponential amount of time to process. Okay? Follow to that one, if you are looking for the parallelized solution, highly parallel solutions, means you are looking for some computational speedups. Yes or no? So the time must be reduced. You will achieve what? Computational speedup. And because as based on the fact of accessing the entire RAM in a single step of execution, you can understand that high dimensional data can easily be accessed by the quantum machine. Understood or no? So whatever the quantum based machine learning solutions are also emerging nowadays, like machine learning and AI people. Okay, you are only dealing with what? High dimensional data sets. Okay, so to deal with such high dimensional data sets, you have the quantum machine as one of the possible solutions. So once you apply such a solution, your high dimensional data set can easily be handled by the quantum machine. Clear? And it can solve the complex problems, for which still the classical supercomputer is still found that is inefficient. That is the key context. These are some knownful things, like you are known, like traveling salesman, knapsack problem, integer factorization. These solutions, if you see, they are still or at least requiring exponential amount of complexities. So these exponential complexities of solution which are available in a classical computing can now be solved using a quantum machine in a logarithmic amount of time. Now you think, if suppose for 1000 number, we have to go for 1000 number of steps to declare our answer. Okay. But in order to show with the 1000, only we need to deal with what? 10 number of qubits. With 10 qubits, all 1000 possibilities can be realized in parallel, and at a single step of execution we can say what? The solution is available inside. Understood or not? So that would be a kind of, that is logic. The people are going to implement within what? The quantum machine. Clear? Now, we come down to the very important factor, that what are the paradigms of quantum computing. Okay, you see, number one, quantum computing using simulation. What does it mean? That we need to simulate the quantum computing behavior in the classical machine. Understood? So I'll ask you to install the simulator. If it is not possible with the hardware limits or whatever the softwares are not available for you, so no problem. You may execute your task on the cloud-based platform through Google Colab. Okay. Otherwise, from the internet itself, you can just download the requisite framework and will just proceed with the program. I'll let you know. Don't worry. Second thing is what? The quantum computing to be applied on a physical machine. Means we need to access the dedicated hardware. Okay. So for dedicated hardware, we need to program a solution. And how to program a solution? We usually write the quantum programs that would generate what? Quantum circuits. Yes or no? And now the quantum circuit will be either executing locally on simulator, or it will be running on the quantum hardware. Okay? But for everything we require what? Quantum circuit to be generated. Another is hybrid quantum classical solutions. So, hybrid quantum classical solutions. What does it mean? It is like an example I shared. Initially the problem comes to what? Classical. If classical inefficiencies remains or persist, then only the solution will go to quantum machine. It is like this approach. It is like this approach, CQ. Classical data to be processed on quantum machine. It's simply saying that initially your problem to be processed by the classical machine. If there exists classical inefficiencies, then only the same problem to be solved by the quantum machine. But when the quantum machine solves the problem, it needs its own data in a compatible format of processing. Therefore, the classical data to be encoded in quantum compatible format of processing. Understood? So, this is what hybridness. And this is the last one, quantum inspired. I told that the quantum behavior can be either simulated by by realizing the quantum environment onto the classical machine, or we have one more option, that we may write the equivalent classical operations that would be equivalently performed as like as the quantum behavior does. Okay, so I will let you know through the quantum programs that how the quantum inspired computing is actually done. Okay, so the research is actually going on in all of these parallel domains. Okay, when the people are realizing their task, so they are giving their solutions in the form of simulations or in the form of practical realizations on the physical device. They are also giving the hybrid solutions. They are like most of the 99 or 100% of the machine learning based solutions are based on hybrid computing. Okay, and at the last, if you see, the inspired computational tasks are also possible, where you require what? Some classical computation codes. Okay, that would be equivalently performed, similar as quantum solutions. Clear? So now you here check that how the quantum technology is actually developing. Okay, I am letting you know here the very genuine fact that we are at the early stages of development. Where? Early stages of development. You all people have the chance to become the part of this quantum computing revolution. You think upon the scenario like in 1800th century. The people initially started thinking there can be some analog machine, yes, that can compute like we can compute. We always run our biosignals in our mind, yes or no, and we usually compute something by our mind, yes or no. So similarly, the people started thinking in a manner, and then analog computers got converted into digitized computers, yes. But if you think upon that era, around early 1900 of century or in the late 1800s of century, but we are living here in this era, we people are now too much concerned with the development of the machines which are still not available. Like classical machines were not available in 1900. Yes or no? The people have put lot of efforts so that their efforts are coming into the picture, and we can use these laptop machines or desktop machines, mobile phones are working as a machines. Yes or no? So right now you are living at the age. At this age, you have the possibility to become the part of the quantum computing development revolution. Yes or no? You may also contribute by your own. And there are several aspects I told through which you may propose your solutions. So once you see, at the early stages of development, at present most of the quantum computing platforms or the hardware are available based on the superconducting machines. Okay? So it is based on some superconducting materials. Okay? So, and it is realized by some Joseph functions. And the thing is that this technology is emerged because of the early stages of development. First, because whatever the technological development the people could incorporate, the people have done it. Okay, but it doesn't mean that only the superconducting based quantum machines are available here in the today's world. The people are approaching from where? From superconducting to trapped ions. Trapped ions to suppose like topological, quantum annulus. Okay, followed to that one, photonic qubits. Means with the early stages of development, we have the superconducting machines. These are 5 different qubit technologies. Okay, based on these qubit based technology. And what is qubit? What is qubit? Now you know. Qubit means a single qubit may realize two quantum states at the same time. Cat 0, cat 1. It is just like an electron that is available in up spin or down spinning state. Yes, it is just simply like you may call it as an electron. Maybe they are in a ground state or maybe they are in an excited state or in a superposition of both. Yes or no? So the things are coming into picture that in this early stages of development we have only the superconducting machines, but we have the roadmap towards what? Towards the realization of photonic machines. Like yesterday I think you had a session related to the quantum communications and cryptography. Oh. So for that quantum cryptography and communication aspects, only the photonic development of the qubit is required. Okay, where the qubits are not realized neither as a part of like electron or as like an atom. The qubits to be realized as a particle of light, that is a quantum particle of light. And what do we call it as? Photon. Lowest particle. Yes or no? As I was discussing with the that is very lower bound theories. Okay. Do you feel yourself as a quantum particle with respect to the entire universe? Can we feel? Yes, definitely we are just like nobody. Yes or no? We are like a quantum particle. And we always remain in a superposition of the states. Yes, we do not have like any deterministic state. Always they are in a superposition. When I just off my class there, okay, and called you all to enter in the lab, everybody mind should be like, should we go or not go? Yes or no? If suppose it is made as a compulsion, no, all should go, attendance would be there. Then few people must have been seated here with their own willingness. And few people are seated here with have to grammar. I have to say. Yes or no? So it happens. But no problem. So understood the context that we have some roadmap towards the technological development of the quantum machines. And these are basically depending upon what? The qubit based realization. Once the qubit realization comes into the picture, then only the hardware can be developed. Okay? Now you see, everything is basically based on the De Vincenzo criteria. Okay? So this De Vincenzo has already given the criteria for the execution of the quantum information. Okay? Simply saying, do not remember any name. Simply the term is what? There should be the existence of the quantum particle. And how do we represent any quantum particle with the cat states? Yes or no? This is the simple one to understand. And if cat state is any of the vector we understand. So how do we perform any transformation onto the vector? Matrices. Yes or no? We perform the matrix based transformation to change the vector from one position to another position. Yes or no? So that is why if you have learned the quantum basic gates, if you remember all gates like polymatrices, Hadamard matrices, okay, like any phase gate operators, control gate, control not gate, control Z gate, etc. All such gates, they all are having the matrix oriented operators. Did you observe this fact? Yes? So this is very genuine fact that we need to digest. Clear? Because the information processing system is completely vector. Okay? And to have such any of the transformations, we need to apply some quantum operators. Okay? It is not like a gate, like a logical gates what to be done, like NOT gate, AND gate, OR gate, XOR gate, XNOR gate. Okay? Here every quantum gate must be what? A quantum matrix. Okay? And that matrix must be unitary in nature. Unitary in nature means the transformation must be reversible. Clear? Like in a NOT gate of classical. If you have the input as 0, applying NOT gate, you are definitely getting what? 1. Yes? On 1 applying NOT, definitely 0. Other than NOT gate, you have no gate whose transformation is reversible. Means what? After obtaining the output, you can't let us know about the what must be the input. Yes or no? Other than a NOT gate. If suppose in an OR gate you are getting the output as 0, can you let me know with the deterministic input? No, because there can be possibilities. Yes. So the thing is that if there exist certain possibilities, okay. So with such possibilities, here in quantum, every gates are reversible in nature, means from input to output we may observe. So from output we may also go towards the input. So the transformation is possible as well as reverse of the transformation is also possible. That is why you must have learned in a mathematical term, unitary, that is known as U. That must be multiplied with the conjugate transpose of the same unitary matrix, that is called as U dagger. Okay, and the resultant must be what? Identity matrix. Yes. So this is the key aspect to understand what your quantum computing technology, and it is completely based on what? The Designation criteria. And this criteria only ensures that once you realize the quantum state of the system, you will have to collapse the state to observe your classical outcomes. Okay. So in order to observe the classical outcomes, we need to measure the state of the quantum system. Yes. So once you apply the measurement, quantum state is lost and you come down to what? Classical outcomes. Okay. So these are still the qubit technologies that are actually being developed for the realization of only the qubits, because if the qubits can be realized, okay, then only the hardware can be developed. Understood? So based on the realization of a qubit as a basic or the fundamental unit of a quantum information, the entire technology is getting developed by the different companies. Okay, actually why this revolution came? Because the industry took the part for the development of what? The quantum machine. Okay, neither I am talking about the academia, not only the academic people, because the solutions we people are having since 1980s. Okay, lot of solutions in the form of algorithm, quantum circuits the people were proposing, but we had no realization of such a solutions. But once the solutions transformed to the programs, and these programs like quantum programs got executed onto the machine, then only everything is started. Okay. Now you listen that again, in order to have the hardware realization, okay, like this is, I told you, every qubit is just working like what? A wave particle to array. So if suppose you are dealing with n qubit system from 0 to n minus 1, every qubit must be realizing some signaling pattern. Okay, and under that signal we have certain amplitudes. Yes or no? And associated to each qubit we have to observe the qubit either in terms of amplitude or in terms of phase related information. Because if you understand, if the vector is available, if vector is moving like, okay, if vector is moving like, if the vector is moving like this, means associated to each vector there is a fixed amplitude in a quantum context, because that amplitude is always set to 1 maximal, because we always expand our qubit onto the block sphere. Yes or no? I think you must have heard about this term, block sphere. The maximum length of any amplitude may be 1, because you know, once you apply the modulus square on one length, you will get the 100% probability. Either the maximum amplitude can be 1 or the minimum amplitude can be 0. Understood or not? Now, so either you have the solution to, either you have the possibility to measure your answer in terms of amplitude, or the phase related information you may also get, like associated to every vector, like this is the vector, okay? Right now we have 0 phase, but once this vector started moving, phase means the angle, how it is rotating. Yes, this is what? 90 degree. 180, 270, 360, coming back. And it is keep continuing with the fact of what? Quantum, because it is following the signaling pattern. And once your entire computation gets done, then we have to go for the selective readout. Selective readout is just similar to what your measurement. Whatever the desired answers you people are seeking from the quantum system, you are going to accept that answer. Clear my point? This is as per your intention. Okay, so how this hardware is actually being realized based on some model of quantum computations. Earlier, based on these signaling based patterns, we are also looking for what? Analog quantum computers. That is completely based on signal based processing. As well as we also have what? NISQ quantum machines. NISQ stands for noisy intermediate scale quantum machines. What? Noisy intermediate scale quantum machine. Means we are here at intermediate scale. Means the scaling of a qubit, like we discussed about 32 qubits, yes, to access a 4 GB of RAM, like 50 qubits, 100 qubits, 1000 qubits, I can say. But do we have the hardware? Yes, we have the hardware. I am letting you know, we have the hardware up to 5000 qubits right now and present. Okay, I'll let you know, no worries. So we have this hardware, but it is for different purposes. Okay, so the thing is what? That intermediate scale means we can scale up our quantum bits. That is the usage of quantum bits as per the requirement what we have. But this cannot be largely extend up to the maximum. Okay, if suppose you require what? 2000 qubits. So for all purpose, the 2000 qubit would not be enough sufficient. Clear my point? Now, the thing is noisy. Noisy is the term included here because we assume this fact that my quantum machine is what? Noisy in nature. Noisy in nature means the noise can have any impact at any moment of time. And once the noise comes into the picture, what happens? The coherence get lost and we perform what? Which transmission? Which transition? Decoherence. Yes or no? Immediately a decoherence transmission get happened with the system and you will get arbitrarily at random any of the possible quantum state. Clear? But our vision is still to have what? Fault tolerant quantum machine. We do not need any fault. We only need noiseless quantum system. But what I told, we are at the early stages of development. Okay, like whatever the laptop machines you people are carrying with your hands, yes, the people started around 100 years back, yes, and now if you see around 40 years or 45 years of time the people have spent, okay, but now after this industry revolution that started from 2008 onward, almost 15-16 years of time the industry people have invested. And we have very early stages of development of such a machines. Understood? So this remains a very general fact for the overall development of the machine because we have the vision to have the fault tolerant machine. But when such fault tolerant machine will come into the picture, that could be again one of the things to be discussed. Recently, there is a notification going on Google, okay, like Windows chip. If suppose the people have got this notification or not, you check. Yesterday only actually they are released. Okay, and they are claiming that a fault tolerant kind of machine that people are about to prepare, which is 13,000 times faster than a classical machine. Okay, they are claiming just it is just available on blog. Understood or not? So they need certain time in order to give the proof. Okay, so we have the enough machines in the form of computational model, and you think upon the scenario that you people are also dealing in the same revolution era, means in the same era of the revolution, and you can participate in the further development of the quantum machines. These are three quantum computers, that is commercialization of the quantum machines based on the noisy analog machines. These companies are working, and this is very famous name, D-Wave. Actually, this company only started the development of the quantum machine in 2008 onward, which was recorded from 2011 onward. Initially, the people were not taking them as serious. Okay, but when they had a significant development of the qubit, the people started thinking. Then came into the revolution the other industries immediately started thinking, okay, if the DWAVE can construct or develop such a model, so how we are lagging behind? Okay, so they also approached for the development of the quantum machine. But here if you see, the noisy gate-based system means the machine is noisy machine, and a gate-based system means quantum gates-based realizations are there, and one of the famous machine is what? IBM quantum machine. Okay, I will let you know. And we have the fault-tolerant based machine. These all companies are working for the fault-tolerant development of the quantum machine. Okay, so IBM is also claiming that around 2030, means around 2030, they will be coming up with a maximum scalability of the quantum machine which will remain fault-tolerant. Okay, almost that is the noise would be reduced. And right now at present also, if you see the hardware, only maximum 1% of errors that are coming under what? The quantum machine. So 1% so we people may compromise. Okay, because we are at the early stages of development, we have no issues. Okay, 99% of the time we are getting the correct solutions. Understood? So now these are still showing some growth based on the development of the quantum devices. I am not going to waste now time because we want to just move ahead with the development part. Okay, so these are certain pros and cons related to what are qubit based technologies. Okay, so what I would recommend that there are certain possibilities that to take the early stages of development to the futuristic development, means from the superconducting qubit towards the photonic qubits, because ultimate development of the qubit is what? Photonics. Okay, once the photonic qubits would be there in realization, means entire communication network be formed with the quantum communication network. And if you see, if you have the quantum communication network, means your internet will also become the quantum internet. You start thinking with this fact, and you may think like it's okay, may or may not possible, but I am letting you know the fact. Europe is very ahead with the Asian people. Okay, the people have started transforming their internet with the quantum communication links only by using the optical fibers. Only based on optical fiber links, the people started what? Transiting from the classical communication system to quantum communication system. Okay, and that only requires what? Photonics or the photons to travel over the optical fiber cables. Okay, so based on such realization, if we have such a vision, and the people are working. I am also investigating one project for the ISRO. Okay, and this project is completely based on the memory-based development to store the photonic state of the qubit. Okay, and this is only for the quantum communication link that is to be established for the satellite communication. Okay, I am already, my project is going on. Okay, too many technical details we people may incorporate, but we can't have the food at the same time, means for the entire life. Okay, so it takes time, you spend some time. Now you think how the quantum bit technologies be actually comparable. Some comparison flowcharts are there, like how your qubits be operating. Okay, like in a superconducting environment, like in a topological environment, okay, like in a trapped ion environment or in a photonics environment. Okay, so based on your operating conditions as well as the connectivities of the qubit, that how your qubits are actually connected, whether they are connected through a closed mesh or a complete topology, or they are independently serving. Okay, so based on the connections what do we have, the quantum based technologies comparison can be made. And if you see here the fidelities, that to ensure that whatever the operation we people are performing on using the quantum gates, that are the reliable operations. Okay, means we will get the corresponding solutions after realizing the particular gate. Like if we have the quantum state as cat 0, applying Hadamard, what does it mean? We assure that if you are applying Hadamard, it would transform the cat 0 to cat 0 plus cat 1 by root 2. It is nothing but it is simply another state called plus state. Yes or no? So to transform or to obtain the plus state, we apply the 1%, so we are compromising still, I told, because we are dealing with what? The noisy intermediate scale quantum technologies. Right now, at present, we are at the early stages. Okay. So, as well as we are looking for the readout fidelities, like measurement possibilities. If suppose you are expecting to measure your answer as cat 0, but instead you are measuring your answer as 1, this may also be possible. Yes or no? Because you are dealing with the highly probabilistic state of the system. If the state of the system is giving you cat 0, means your desired answer. So sometimes there may be a chance that you will get the undesired or non-desired answers. Understood? So, and the coherence time will also play a very crucial role here, because the qubit stability we actually always seeking for longer duration of time. If you maintain a quantum stability for longer duration of time, then the overall computation can be made very fast. If suppose that there is no stability in your qubit, means the coherence time is very small, means immediately the decoherence transition can happen. Okay. So with such fact you cannot guarantee that the quantum computations are actually be happened. Understood or not? So several facts are there. Based on these comparisons, you can further learn about the quantum based technologies. Okay. Now they are the superconducting. These are some that is core technical details related to the technologies that we need not to discuss here, because we are here dealing with what? The comparative factors. Like here we are looking for the speed, noise, scaling of the qubit, connectivity of the qubits, the operating conditions, fidelities, like the reliabilities of performing any operations, scalability, maturity. These all are the fundamental parameters to compare the quantum bit as a possibility of technology. Okay. Now, how we are dealing with the technology-based platform? Because we know there are 5 different technologies, okay, through which the quantum bits are realized. Like superconducting, trapped ion, we have the topological, we have what annulus, we have what the photonics. Based on these, do we have a specific quantum machines? Yes, we have the definite quantum machines like this D-Wave. D-Wave is working on the annular based technology, quantum annealing. It's completely based on combinatorial optimization, solving of problems. Okay. Now, IBM people, they are developing the machines based on the superconducting environment. Okay. So IBM actually contributed a lot for the development of the quantum machine. D-Wave is very personalized. The IBM quantum has given the freedom to all people throughout the world for the development of the quantum machine. They have given you the access to the quantum machine free of charge for 10 minutes, free of charge. That is 10 minutes per month of time. And if you think like that 10 minutes, what we can do with 10 minutes, it's still very enough for the beginners of the quantum computing. Clear? So if you are the beginner of quantum, because when you run your task on a quantum machine, it hardly gets executed in 1 second or 2 seconds of time. Now you start calculating your seconds that is available in what? 10 minutes of time. So the simply thing is that you have the enough time to code your quantum circuits and to run your quantum circuits on the IBM hardware. Okay? And that is also giving the scalability, like the free access to the 133 and 156 qubits of quantum machine. But the IBM nowadays already made up with 1000 qubits of machine. Okay? Already the people have made up with 1000 qubit of machine in 2023 itself. But in 2023, IBM were very happy that we have developed the 1000 qubits of machine. But at the meanwhile time, the D-Wave announced 5000 qubits of machine. Okay, they announced, but they are not giving for any personalization use. Okay, they are taking their own development of the machine, dedicated developments. Okay. Now this is the IBM computer based development. They have when you visit their own sites, like only you write down IBM quantum, you go to the site, visit the site, you will find every information related to the quantum computing and the corresponding hardware. Similarly, when do you visit the Microsoft Azure, like You listen. Very important fact to be discussed. Like quantum, IBM Quantum is a dedicated platform and direct platform for the access of the quantum machine. Okay, you people may directly approach to the, or you people may directly sign up with the IBM account. You may run your quantum circuit directly on the hardware. But what the other people are doing, because the market, it's a market strategy. Microsoft thought, I am lagging behind with the development of quantum. So what to do? So now they come up with what? They came up with what? Cloud-based solutions. They had the tie-up with some quantum hardware-based development of the other companies. Okay, and they are just giving the interface of their quantum computer through their cloud platforms. Clear my point? So they are like working as a third party. Okay, like if you see the Quantum, this is developing one of the quantum hardware technology. Like Rigetti is also one of the superconducting technology that is getting developed by the Rigetti hardware. Okay, but they had a tie-up with the Microsoft. Okay, and their resources are freely available on the Microsoft Azure platform. Okay, similarly, if you see Amazon Bracket is also a cloud-based that is facility available for you all people that to program the quantum machine. Okay, so for the programming of quantum machine, like a trap based quantum machine is there, like superconducting quantum machine like Rigetti is there. Okay, so different technologies oriented quantum hardwares are available which are getting provided by what? The cloud-based platforms. Okay, now you come down to the picture and now your task starts. Okay, we are here to learn about the programming framework. Now you understand completely that we have some hardware, and for the realization of the hardware we need some qubit technologies. What are the possible technologies? Superconducting is there, trapped ions are there, topologicals there, annealers there, photonics are there, and these are still not limited. We have other atomic based technologies that is to be realized. Okay, like spintonics are there, like nuclear atoms are there, but I have not included this thing because too many broad things are there in order to discuss. Now, but the ultimate goal is what? Ultimate goal is what? To transform our solution in the form of quantum circuits. But to transform the solution in the form of quantum circuits, we require what? Quantum programs. So for writing the quantum program, what we need? Programming frameworks. Yes or no? Without programming framework, we can't do anything. So we have several programming frameworks like IBM Qiskit. Qiskit is actually a very popularly known quantum-based programming framework for the realization of quantum-based solution. Clear? We have other platforms like Google. The Google has already come up with what? SONI-QUANTUM. The SONI-QUANTUM is also one of the famous quantum-based programming framework. And for the specifically for machine learning and AI related tasks, you have the platform that is developed by Xanadu. Okay, it's a Canadian company. They are developing a photonic quantum machine. Okay, so Xanadu people are working for the development of the photonic quantum machines, and for the realization of the quantum AI or quantum machine learning based solutions, you may use the Paneling as the open source library. Okay, so here, like what was the data set? CC, CQ, QC, QQ. Yes, here at Paneling itself, you will find QQ. They have very limited size of data sets, okay, available in quantum. Directly you take their quantum data sets, directly you apply onto the quantum algorithm. And remember the model of computation, everything should be there on the circuit itself. Your data should be on circuit, your algorithm should be on the circuit. Once you pass this circuit to the quantum machine, the circuit will be executed on the hardware. Okay, and at the last, the output will be generated based on the classical outputs. Okay, now you see, these are the possible framework that is comparison, but among all the comparators, if you see, Qiskit is very popularly known. Okay, why? Because it is having several features like open source. If something is available as an open source, so we can just go through direct. Okay, and it is giving you what? 10 minutes of free time per month basis. And the Qiskit is having 4 different components, and how these components are actually working, you just look at this programming framework. This is, if you understand this pipeline, this is published by the IBM people itself, okay, based on the Nature Journal. If you see, whatever the problem you have, look at here, the board. If you have whatever the problem you have, for which the classical machines are inefficient to solve, in the context of hardness or in the context of processing of the data, whatever it may be, okay. So if you have the problem, that is to be mapped onto the circuit, okay. Now your quantum circuits would now be passed to the pass manager. So the pass manager would again be a program here that would take care of performing the transpilation related task. Instead of writing the compilation, it is written as what? Transpilation. Why transpilation? I told you. We usually propose the solution in the form of quantum algorithm. Yes, it is our responsibility to transform our algorithm into quantum circuit. Yes, so you have done it here. Now the quantum circuits are ready and your quantum circuits are passed to the compilation task, and that compilation is here called as transpilation. So what this transpilation will do, it will do the compilation of your circuit first. Okay, so your circuit would be compiled, whether it is correctly created or not. After that one, it will perform some optimization task onto your circuit. Means whatever the circuit you prepare, it will again re-prepare the circuit for the target backend. A target backend may be depending upon the hardware, how the hardware is actually developing, maybe based on superconducting or any of the up to photonic qubits. Clear my point? Now, but IBM is specifically for the development of superconducting machines. Okay. After that one, what we require? We require the execution of the optimized compiled circuit. The circuit is compiled and it is optimized circuit, and we want to execute that task. But once you start executing your task, means your program must be running either on simulator or it must be running on the hardware. There are 2 different components which are parallelly working. One is known for sampler, other is known for what? Estimator. What are their own purposes? You try to, because it's a probabilistic computational model. Okay, so sampler actually will take care of the distribution of the probabilities of all the quantum states that is available in your quantum system, and estimator will actually compute the expected value of measuring your desired answer. Getting my point? That is to get the, that is, it's all about the computation of the random variables. Okay, like how do we compute? We are looking for the expected values of the random outcomes. Yes or no? So these expected values be calculated by the estimators. So based on the expected values of the estimator, once you start performing the measurement, so based on the estimator's value, your measurement actually be done. Okay, so once you measure, means this is the task of post processing. Okay, post quantum processing means quantum is over. Now you are having your classical outcomes. Now these classical outcomes can be submitted as a solution to the end user. Understood? So this is a simple pipeline. What is a pipeline? You have the problem, identify classical inefficiencies. If yes, encode your problem in the form of quantum algorithm, convert your algorithm into quantum circuit. Now your circuit to be transpiled. Transpile means your circuit will be compiled, followed by further optimized. After that one, execute your quantum circuit, measure your answer as per the DiVincenzo criteria, and retrieve your classical solution. That's a very simple model to understand here. Okay, this is one of the famous video I used to actually play. This is associated with voices there. Video can be played here.
Video can be played?
Can the video play?
Yes.
Okay, so if yes, so you see. Oh, but it requires internet connection. You see, this is only for motivation. What we people are learning Okay, since my session also, and not only my session, you people have been learning. So, sir, what is the password? Which one? MTC11. Correct the password. Only see it's a 2 minutes video. Okay, it will motivate you to learn quantum. Okay, nothing else. Just wait for a while.
Sir, while that notes, can you tell us what are the expected salaries at the in this domain?
For industry person, there is no bar winner. Because entire world is actually struggling to get the skilled person.
As a fresher?
As a fresher, so now actually there is no bar, I told. Because the thing is that the technology is emerging, but we have no skilled people, that those who can work for this technology. Like India has initiated National Quantum Mission, you must be known, with 6,003 crore rupees of funding amount. They initially started asking for call for project proposals, but they realized very less and very vague proposals they received last year. Okay, so why they realized? Because the people are not skillful people, so they are not writing the correct proposals. That is the first. So now they started thinking for the skill development. Most of the AICT, like this program is going on. If you propose any course on quantum, you will get the corresponding approval. Very rare proposals the people are receiving. It's okay. You see. You just please see this 2 minutes of video.
The quantum computer that can compute many times faster than the current new system of computers. A successful quantum computer could crack any code on the planet Earth.
That's what's exciting about quantum computing, and that's
quantum computing is a fundamentally different computing paradigm, and it's one that offers a substantial improvement over known classical approaches for certain types of problems. Whether we're talking about supply transport or optimization problems, pharmaceuticals and drug discovery, or cryptanalysis. These are areas where quantum computing will really shine.
Quantum computers are not just smaller, faster versions of classical computers. They're fundamentally different.
This program covers the basics of quantum communication and quantum computing. And it's particularly designed for senior executives, mid-level management, people who want to learn about quantum computing, what it's good for, what's the state of the art, and where it's going.
With quantum computers, we get this ability to take a step closer to being able to actually computationally model aspects of physical systems.
We designed this course as a guided discovery to the algorithms that we use on a quantum computer. We had access to a broad range of expertise, both in industry as well as in government labs.
single qubit, double qubit operation.
We didn't get a chance to implement these algorithms on the IBM quantum computer.
This is not decades away or 100 years away. That quantum age has now come.
Many researchers believe that quantum computing will be for the 21st century what classical conventional computing was for the 20th century.
We have a number of algorithms that accelerate the solution of difficult combinatorial optimization problems.
That's my fun. That's what I'm there to see. What can we do to enable that increased complexity of these qubits?
We're really here at the very beginning of this. I just find that tremendously exciting.
Thank you very much for spending your time. It's a release video by MIT people, okay? So it's only to just make you all motivated towards the development of the quantum machine. I already told you that this requires a fundamental different form of the computation. And what the people are saying, quantum age came already. You are living in the quantum computational age. And you have to, you can become the part of what? This evolution. No problem. Now, this is all about that is further programming, because we are about to program. Now, are you ready with your machines? Okay. Now you have the two choices. Either to run your programs directly onto the IBM composers. Okay. Otherwise, we have also the possibility to realize the code onto what? Our local machines. Okay. So first, let me tell you that how many possibilities are there. That is the first one. You understand? The quantum codes can be executed on the different environments. If you see, the code can be executed, like the quantum programs can be executed on the different platforms. That is the first thing. Okay? You look at me. I told that IBM is having a superconducting technology. Yes? I already shown you that the Microsoft is giving you the access related to reggaetic machines. Okay, quantum machines, okay, based on IM technology and what? Based on superconducting technology. Amazon Bracket is also giving you the access for the different technological hardwares. Yes or no? So, but they are what? The third party access. Direct access is IBM. So, what you can do, you can run the realization of your quantum problems, okay, on the different platforms using different programming frameworks. Okay, like the same program of realizing superposition, you may execute using what? IBM. You may Qiskit. Okay, you may execute using Google Circuit. You may using from the photonics development like Xanadu. I discussed. Okay, so by Xanadu you may execute your task by using Parallel library. Okay. So multiple platforms or based on multiple programming frameworks, you may realize the same task. Okay. Otherwise, if you are specifically talking about the IBM Qiskit, these things you will not find on the IBM Qiskit platform also. I will let you know all the possibilities, okay, through which you may realize your code. The first thing is what? The Qiskit code you can run locally on the machine. That is called as what? Quantum simulation. Yes? So we have to install the quantum simulator locally in our machine. Then we have to code our problem in the form of quantum circuits. Now the circuits we executed on the classical machine. That is the first context. Like this. Okay? Now second task is what? You can execute your codes locally on your host machine. Okay? Like on your local host. Okay? You may initiate your task. You may run your task on your local host machine, but still it is a simulation. Third task, what you people are going to prefer, because you all were concerned with can we do it like on Google Colab? Yes. So the third is giving you the flexibility that execute the Qiskit code at the cloud using what? Google Colab. Why only Google Colab? Because the Google Colab is giving you the Python enabled environment. Yes. So, and Qiskit is what? Python enabled framework. So, it requires a Python environment first. That is the key context. So, that is why it is suitable to code on the cloud-based platform that is supported by what? The Google Colab. But still remember, this is not the real execution. This is still simulation. Okay? Because the backend you are using, that would be the classical machine. Okay? Now, the fourth thing is what? That you may execute the Qiskit code. That is, from the IBM cloud, from what? Local machine. Means what? I can write my own program in my locally on my machine. I can initiate my task that should be submitted to the cloud server. Cloud server must be a quantum processing unit. Okay? So, my task would be submitted to the cloud server and the cloud server will run that task. Okay? Otherwise, we have the direct option. You may execute your quantum circuit directly onto the IBM cloud machine, okay, using a Qiskit composer. So, I'll let you know because we are limited with the time now. Some very easy options that you may all realize right now the codes in your context. Now, if you see, this is the code. This is the code related with what? Qiskit. What it is written, you see, this is what? Qiskit. So based on Qiskit, I realize what? Superposition. Here you see, this is only the logic of the code. What I required to construct a quantum circuit with one qubit and one classical bit. Okay? So with one qubit, one classical bit, I have made one circuit And on that circuit, on the zeroth index initialized qubit, I am applying the NMRT.